indicators, mainly from the, again, chapter 18, pH and indicators. So I suppose, what is an indicator? So an indicator is a substance that changes colour, okay? So it indicates, by changing colour, the pH of a solution, right? So it'll tell you, by changing colour, if it's an acid or if the indicator has been put into a base. Most indicators are used to determine the endpoint of acid-base titrations. That's their function or their purpose. It'll tell you when you've added sufficient acid to neutralise all the base that's in the conical flask. Because remember, at neutralisation, at the end point of the titration, the number of moles of acid delivered to the flask must be the same as the number of moles of base that's in the flask, you know. Now, most indicators are actually weak acids themselves, and you might be asked to show how it acts as a weak acid, you know. So you would use an equation like I have written here already. So H, if it's an acid, it has to have a proton. So HIN. And then look, it's a weak acid, so you've got the reversible reaction arrow here. Donating, how do acids behave? So if it's a weak acid, it's going to donate a proton, and then the IN minus is a different colour. So as it dissociates, it's got two clear colours. So the red colour when it's associated, and when it's dissociated, then the indicator has a different colour, okay? Now, what about if you were asked to show how it acts as an indicator? So you might say, remember for equilibrium we had, what's the stress, what does the reaction want, and how? So say, for instance, you put this indicator into acid. Well, what's the stress there? Acids are proton donors, so you would increase the concentration of H+. The reaction, according to Le Chatelier, will want to decrease the concentration of H+. And then the question is, how will that reaction up there decrease the concentration of hydrogen ions? It'll move to the left. So the equilibrium moves to the left in order to decrease the concentration of hydrogen ions. As it moves to the left, yellow turns red. Always give the original colour as well, okay? Now, what about if you put the indicator into base? Well, what do bases do? Bases accept protons. So what would happen is that the hydrogen ion concentration would decrease because the base is accepting the proton. According to Le Chatelier, the proton concentration would want to increase. And how you move it to the right. So you're moving the equilibrium over to the right in order to make more hydrogen ions, in order to increase the concentration of hydrogen ions. So what would you observe then? You'd observe red turning yellow. So that's showing how indicators work as weak acids. Now, sometimes in the titration question, they might ask you, why do you only add a few drops of indicator? Well, the reason you only add 1 or 2 drops of indicator is because the indicator itself is a weak acid. So by you putting more indicator into the conical flask at the start of the titration, you are changing the pH of the solution in the conical flask. The indicator will change the pH of the solution, and then that will affect the accuracy of your titration, because the solution in the conical flask isn't as basic as what it was in the pipette. Does that make sense? So the accuracy of the titration would be affected because the indicator is itself a weak acid. So sometimes in a question 1 for acid-base titration, if they ask you that, why only add 1 to 2 drops? That's your answer for that, okay? Now, now just before I move on, actually, the other thing they might say to you is some indicators work as weak bases. And remember, that was our thing for a weak base. So make up a colour for this and make up a colour for that. And it's in your notes. We did that before school finished up. So you'd be using a similar sort of thing there for that, okay? Now, the next thing I want to talk to you about here, look, is the range of indicators. So the range of the indicator is a pH range over which there's a clear change in colour. So, for instance, if you take methyl orange there as an example, can you see the range of the indicator? So, methyl orange is clearly red below 3 and it is clearly yellow above 5. So, the range of the indicator is where there's a clear change in colour. So, it's clearly red below 3, and it's clearly yellow above 5. pH 4 methyl orange is a kind of an intermediate, a mix of red and yellow, and it's not it's not a clear colour. So the range of methyl orange is where there is a clear change in colour for the indicator, okay? That's the pH range. So below 3 methyl orange is red. Above 7, above 5, methyl orange is yellow. Litmus's range is between 5 and 8, which means that below 5, litmus is clearly red. Above 8, litmus is clearly blue. And phenolphthalein, watch the spelling of phenolphthalein. Phenolphthalein, below 8, phenolphthalein is colourless, and above 10, it's pink. So it's just, don't overly worry about it. You are supposed to try to remember the ranges of the indicators, but so maybe just if you could just remember methyl orange and phenolphthalein, you won't use litmus really. But it's the pH range where there's a clear change of colour. Okay, now if you know, when I was in school, or when we were all in school, I did a titration with you, and do you remember I put the acid into the beaker, which is unusual. Why did I put the acid into the beaker? I put the acid into the beaker because I wanted the pH to start low. If I had base in the beaker, where my pH meter or sensor was, then my pH would have started off, my graph, would start off with a high pH. This is actually, if you wanted to have a look at page 157 there of the revision book, they show you how you can do a titration. And remember, I used the pH sensors, and we used the laptop. I mirrored it on, and you could see the curve, the titration curve. So you see the bottom here, look, it's showing you volume of base that's being added. So I would have had acid in the beaker, so you are starting off with a low pH, and you're adding base in from the burette, so the pH is increasing. Now look, where do you see a sudden jump in pH? So this determines the end point of the titration. So where there is a sudden jump in pH, that's the end point. Now you're going to have to remember, for a strong acid and a strong base, you are going to see that sudden jump in pH between 3 and 10. Okay? Now, the question then in question 1 will be, what indicator would be suitable, and justify your choice of indicator. Well, any indicator whose range lies within that sudden jump will be suitable. Okay? Now, in school, we would have done sort of a thing where I would have divided up the page, say, up into, we had methyl orange, then we had, I just want to change that. So we had methyl orange, then we had litmus, and then we had phenolphthalein. Now, if it's a strong acid and a strong base, you want an indicator to tell you where there's a clear change in colour between 3 and 10, okay? 3 and 10. So say to yourself, well, what colour would methyl orange be at 3? At 3, methyl orange is red. What colour is methyl orange at 10? Methyl orange is yellow. Would that methyl orange indicator tell you clearly where there's this sudden jump in pH? Yes, it would, because it changes colour. Litmus, red and blue. Litmus would also be okay. And phenolphthalein, below 3, phenolphthalein is colourless. Above 10, phenolphthalein is pink. So actually, any of the indicators would be okay, or would be suitable for use. So if they say to you, what indicator did you use for your titration of HCl and sodium hydroxide? You'd say methyl orange. Why did you say methyl orange? Because the range of the indicator lies within that sudden jump in pH which occurs at neutralization. That is all you have to say. So you're going to say that the range of methyl orange lies, so methyl orange is red below 3 and it's yellow above 5. That lies within the sudden jump in pH that occurs in the solution at neutralization. Okay? Now, remember then we would have spoken about a strong acid. We would have spoken about a strong acid and a weak base. Okay? Strong acid and a weak base. Where do you see the sudden jump in pH? Between 3, because it's strong acid, so it's starting at 3, but this time it's stopping at 7, the sudden rise in pH. So this is the end point. So we want an indicator now that will tell us when this endpoint has occurred. So it needs to be one colour below 3. So methyl orange is red below 3, and methyl orange is yellow above, or is yellow at 7. Okay, does that make sense? So methyl orange is red below 3, yellow above 7. What about phenolphthalein? Would phenolphthalein be suitable? Well, at below 3, phenolphthalein is colourless, okay? So phenolphthalein is colourless at 3. And at 7, phenolphthalein is also colourless. So would phenolphthalein be suitable as an indicator? No, it won't, because it's not clearly changing colour and telling us where the endpoint occurs, okay? So we need an indicator that changes colour within that sudden jump in pH, okay? And methyl orange will do that for us. Methyl orange is red at 3 and methyl orange is yellow at 7. Okay, phenolphthalein is not suitable there. Now, the one that they might ask you for the purpose of question 1 is the weak acid, because we used ethanoic acid or diluted vinegar there, okay? Now, look at this. Look at where you have, now this is a weak acid, so it's starting at 7 and the endpoint finishes at 10 because it's a strong base. So this is your vinegar. This is the one they'll ask you now, okay? Here's your vinegar titration. Now, why can't you use methyl orange there? So does the range of the indicator lie within that sudden jump? No, it doesn't. Methyl orange's range is 3 to 5. So ask yourself, at 7, what colour is methyl orange? Yellow. Okay, at 10, what colour is methyl orange? Yellow. Cannot use methyl orange in such a titration because it does not change colour within the sudden jump in pH of the solution, which determines, or that's where the endpoint is. So if you want to use an indicator to determine an endpoint, the range of the indicator must lie within that sudden jump, because that sudden jump is where you have neutralization, or that's where you have your endpoint occurring, okay? What indicator can I use to in a titration between a weak acid and a weak base? You can't use any indicator. There is no sudden jump here, and if there's no sudden jump, then there's no, an indicator isn't suitable here for you to be able to determine the endpoint. Okay.